So today we're going to be learning about navigating the periodic table and how the periodic table can display trends and information about different elements. So the organization of the periodic table, the 1 through 18, or our columns up and down, are called groups and families, and then our rows left to right, the 1 through 7, are called periods. Groups and families can display information regarding how many valence electrons an element has, 1, 2, 13, 14, 15, 16, 17, and 18. Display how full a valence electron shell is, which is that outer ring. If it's 1, it only has 1, and then all the way to 18, it has a full valence electron shell. For periods, it can be how many energy rings or how many valence electron rings an element has, getting more rings as it goes down. And then our bottom two chunks, we have the lanthanized series and the actinized series. It's a little chunk of the periodic table, the two rows that kind of hang off. They're just different because of the attributes of elements and their radioactive attributes. And then if you look where the asterisks are, that would be where the actinized and the lanthanized series would fit into the rest of the periodic table based on its atomic number, which helps identify an element. Going in more about groups and families, there's 4 main types of groups and families that you would be tested on during tests like TMSEA. The first one in row 1 being alkali metals. These are the common everyday metals like lithium and potassium. In row 2, you have the alkaline earth metals. This is in group 2, and these are elements like magnesium and beryllium. In group 17, you have the halogens, and then group 18, you have the noble gases, which are unlikely to bond with other elements. And then in the middle, 4 through 12, we have our groups of metals called transition metals. These are your very stereotypical metals. Okay. So next, the organization of the periodic table, depending on how metallic an element is. Our blue is all of the metals on the periodic table. Our green, that staircase, is called metalloids. These are elements that have properties of both a metal and a non-metal. And then our red are non-metals, but keep in mind that this right chunk isn't just all the non-metals. There's also hydrogen, which is on top of the metals. So don't get confused when an element's being asked about what's a non-metal, because hydrogen is a non-metal. Hydrogen is not a metal. Also keep in mind that this doesn't determine the state of matter of elements. There are metals that are liquid and solid. There's non-metals that are liquid, solid, or gas, and so on and so forth. Same for metalloids. Okay, so next we're going to break down an individual element. The first thing is this number. It can be in the top right corner, or it can be on top of the letter. It's called the atomic number. This is a way of identifying an element. It also displays the number of protons in an element, which the number of protons and the atomic number will always be the same for that element, even if it's an isotope. And for a stable or a neutral atom, it can also display the number of electrons depending on the type of atom, but it will always display the number of protons, and it will never change. It would always be the same for the element. Next, we have the element symbol, or sometimes referred to as just plainly symbol. It's the alphabetical abbreviation for an element. Keep in mind that it doesn't always have to be the letter that the element starts with or letters. I just picked hydrogen because it's really simple and easy to understand, because hydrogen starts with H and its element symbol is H. And this is how you identify an element the easiest way. And then atomic mass is the number of protons plus the number of neutrons, and it's the mass of an atom. So for example, for hydrogen has 1 proton and 0 neutrons, so that's why its atomic mass is approximately 1. Next, we're going to go over a few periodic trends. Electronegativity, force of attraction, and ionization energy. They increase as you go left to right across the periodic table. This can be true because of number of valence electrons, and the fact that your atomic radius is also decreasing because you're increasing your amount of valence electrons, but you only have like one ring and such. Okay, so going down, our electronegativity, our force of attraction, and our ionization energy, they decrease, and this is also because of the atomic radius increases as you go down. And just if you're wondering what atomic radius is, it's the distance from the nucleus to the outer ring. And how you know this is because remember how we talked about earlier that periods show how many rings an element has? So as you go down, it's having more rings, so more distance from the outer ring to the nucleus because it's getting more rings. Lastly, we're going to go over orbitals. Orbitals are kind of like a mathematical way of displaying elements. These two first groups, group 1 and group 2, and helium are part of the s orbital. Then 3 through 12 are a part of the d orbital, and then this pink area, which is metals, nonmetals, and metalloids, just this kind of quadrant right here, is the p orbital, and then on the bottom is the f orbital. Okay, that's all I have. Hope this helps you understand the periodic table. Make sure to comment down below if you have any suggestions or questions, which I'll try to answer, and then subscribe. Thanks.